Hi there, welcome back to this channel. Now let us discuss pure and impure substances. Now beginning with pure substances, what are pure substances? Okay, basically the first thing you should know is that these are the two categories in which you split substances to on earth, all matter. The matter is either pure or impure. Now when will you call a substance pure? A pure substance is one that contains a uniform and definite composition. It has a uniform and definite composition. And let's break those two down. What does that mean? What does it mean to be uniform? Uniform means they have um, um, the same kind of molecules, the same kind of particles. Definite composition means that every time they appear or every time you see that substance, you always see it in that amount. You always see it being combined in that way. You always see it, you always see those substances in that exact proportion. That is why we say they have what? Definite composition or uniform composition. Uniformity is in the fact that they contain the same. So we say they contain the same atoms or the same particles, or generally just say the same particles, which are atoms or molecules. Is that okay? So they contain the same particles, so we call them the same atoms or molecules. Now, another thing with pure substance is that we said they have uniform and definite composition. The other thing is that they have a consistent physical and chemical property. A consistent physical and chemical property. So which is lacking in impure substance. Impure substance change in their physical and chemical properties. But with pure substances, you find a consistency in their physical and chemical properties. By the time we get to the examples, you are going to understand. Now, for example, the boiling point of water. Water is a pure substance. Now, the boiling point of water is 100 degrees Celsius. So every time you take a pure water, when you boil it under a due condition, under normal circumstances, you should boil at what? 100 degrees Celsius. Do you understand now? All right. Now, now let's take examples. Now, pure substances are grouped into two. We have elements and we have compounds. So all of our elements that we have discussed, all of our elements are first 20 elements, the 180 elements, they are all what? Pure substances. Because if you remember the definition of elements, we say they are substances that cannot be split into other substances by chemical process, right? So for example, if I have carbon now, carbon, there is no chemical process by which I can break down carbon to form something else, right? If I break down carbon, what I will see is carbon, carbon atom. Do you understand? So that is what an element. That's why it's an element. That's why elements are pure. So our elements carbon, our elements calcium, our elements aluminium, etc. Our elements thorium, all of them like that. They are what? Pure substances. So the second is compound. Now, a compound is two or more elements chemically combined. Once they are chemically combined, they most likely have a chemical formula. And so if they have a chemical formula, it means they have what? A definite composition. It means that we are sure what they contain. They don't contain vagaries of stuff that are not defined. So when they have a chemical formula, it means that they are what? Pure. They are pure, so they are compounds. So an example is water. I mean, you know with the formula H2O. We have quicklime, we have quicklime, we have CaO or quicklime, we have ammonia, we have, name it, NaCl, table salt. All of these guys are what? Pure substances. Because every time we find them, what we see is NaCl, NaCl. Do you understand? So they are pure substances. Is that clear? So now what are the characteristics of pure substances as we just said now? What are the characteristics? Number one will be what? We call it fixed composition. They have what? A fixed composition. It means that their composition does not change. They have a fixed composition. So that fixed composition is in the fact that they have uniform and definite composition. They have a uniform and definite composition. It doesn't change, and it contains the same type of molecule, the same type of atom. Do you get it? Right. Now another thing is that they have they are homogeneous in nature. We've talked about that. They are homogeneous in nature. So homogeneous in nature is that it's just about the fact that they have definite composition. That is, they contain the same entity generally. Is that okay? Anywhere we see NaCl, anywhere you see pure water, as far as it's water and it's pure water, it is always containing H2O. H2O, never any other thing. Do you understand? So we say it is a pure substance. It is a pure substance. Now another thing is that pure substances have irregular melting and boiling point. Their melting and boiling point is definite. So we call it definite. Melting and boiling point is definite. So for pure substances, the melting and the boiling point is what? Definite. That is, does not change, isn't it? The melting and boiling point does not change. That's the meaning of melting and boiling point is definite. So for example, under normal circumstance, as far as it is pure water you boil, it must, you put it on you apply heat to, it will boil only at 100 degrees Celsius. Is that okay? So that is what we have melting and boiling point being definite. Do you get it? And of course, they have chemical stability also. We call it chemical stability. They have chemical stability. And what do you mean by that? It means that the chemical properties of that substance remain the same. What it reacts with is what it reacts with. What it doesn't react with is what it doesn't react with. Is that okay? You have what? Chemical stability. Definite melting and boiling point. They are homogeneous in nature. They have fixed composition. They have fixed composition. So these are the properties of pure substances. Now, let's go on to impure substances. Let's learn of the impure substances. Impure substances. All right. Since we said pure substances have uniform and definite composition, then this guy will have what? Non-uniform and what? Indefinite, right? Indefinite composition. So it means that their composition is, you can't define it, because e.g. is flood water. Flood water here may contain, it's going to contain vagaries of things. And pure water in another place, flood water in another place is going to contain vagaries of things. But the things that they contain will not be equal, because the component of that flow data is going to be determined by where it passes through. Do you understand? Is it clear? So in impure substance they have what? No uniform or definite composition. They don't have. Is that okay? And of course, what would the effect of that on their chemical and physical properties? It means their chemical and physical property is never consistent. Is that okay? There is never consistent. Another name for impure substance is what? Mixture. So one major difference between pure substance and impure substance is that pure substances usually have chemical formula. So compounds have chemical formula. Mixtures don't have chemical formula. Is that okay? So, and the way we even define it, a mixture, let's define a mixture. A mixture is a substance that is a combination of two or more substances, two or more substances that are physically combined. That are what? Physically combined, but not chemically combined. What's a mixture? A mixture is a substance, is a combination of two or more substances that are what? Physically combined, but not chemically combined. Right. Good. Now let's talk about the types of mixtures. Number one, we have the homogeneous, homogeneous mixtures. Now, when do you call a mixture homogeneous? When do you call a mixture homogeneous? In fact, we said homogeneous mixtures are the ones we call solution, right? Yes, and that's because they have uniform, what do you say now? Uniform composition, and homogeneous mixtures they have uniform composition. Is that okay? But not the uniform composition now is not in the particles themselves. The particles are not uniform. Do you get it? But we mean uniform composition in the sense that the substance that are there are all they are evenly distributed. They are what? The particles that make it up are evenly distributed. So evenly distributed. So another name for homogeneous mixture is a solution. So we said the particles are evenly distributed. Now, I talked about melting and boiling point the other time, and I didn't mention it. See, if you add impurity to a pure substance, what it does is this. You know, we have boiling point and we have melting point. Are you with me? Now, if you add impurity to to a to a pure substance, so say for example you add salt to water and you want to boil the water. Is that okay? The water will boil at a temperature that is greater than 100 degrees Celsius. And it will melt as a temperature that is lower than 0 degrees Celsius. So 0 degrees Celsius less than 0 degrees means minus something, minus something. That's where that substance will melt. And this one will boil at 100 degrees Celsius. Exactly. All right. So this one will boil at greater than 100 degrees Celsius, I meant. When you add impurity to a pure substance, is that okay? It increases the boiling point and reduces the. Is that clear? When you add impurity to a pure substance, it will increase the boiling point of the liquid but lower the melting point of the liquid. Is that okay? Okay. So let's go. Let's go. Now some. Let's consider some examples of homogeneous mixture. So example of homogeneous mixture that we said solutions are air, and the components of this air. The reason why air is a homogeneous mixture is because it contains, a fine blend of many gases. So we have the following gases: N2 gas, which is about 78%, oxygen gas, which is about 21%, CO2 gas, which is about 0.03%. This one 21%. This one what? 78%. Good. Now, how about the rare gases? 0.1%. Do you understand? Then we now have dust and we also have water vapor. Water vapor. You said it to what? Variable. Is that? Okay, we said because of the relative humidity, right? Water vapor, H2O vap, is going to be what? Variable because it depends on the humidity of the environment. Does that make sense? If the relative humidity is high, water vapor will be high. That's what it. If the relative humidity is low, water vapor will be what? Low. Alright. Now let's go to the second one. Heterogeneous mixture. Heterogeneous. Heterogeneous. The word, as we said, the word homo here means what? Same, right? Gene means origin, right? So hetero will mean what? Different. If homo means same, hetero means what? Different. So it means that this one have, we said here, this one have uniform what? Composition. This one will also have what? Non-uniform composition. Non-uniform composition. Then he said that the molecules of this one, the particles of this guy, they are evenly distributed. What would this one be? Now, it says that heterogeneous are non-uniform. They are also unevenly distributed. They are also what? Alright. Is that clear? Should I write down, make it bold? And it's just the opposite of what we had before. You get it? This one, uniform composition and even distribution. But for impure substances, you have non-uniform composition and non-uniform composition and unevenly distributed particles. Is that okay? Okay. Now let's go to the next thing. Now that we know pure and impure substances, now let's talk about some of their differences. Now these homogeneous substances, we've talked about the fact that they are uniform all through. But one other thing is that these guys are, they are, you know, they are particles. The particles of these homogeneous molecules, their particles cannot be seen. Is that okay? Once the particle can be seen, it's going to be what? A distributed. Um, are you? We said that these guys homogeneous mixtures. So we have the fact that they have uniform composition and are evenly distributed, right? So it means that they their particles, we said their particles do not do what? The particles of this guy are what? Visible, right? No, homogeneous. They are not visible. While the particles of this guy are what? Visible. Another thing is that it costs more to get homogeneous mixtures because, to separate them, not even to get them. To separate homogeneous mixture is harder than separating what? Heterogeneous mixture. Are you with me? To separate homogeneous mixture is harder than separating heterogeneous mixture. Okay. Now, so that's that about Listen, did we give examples? We gave example of air here for homogeneous mixture. Air and alloys, all the alloys of metal. We said alloys, they are cement, right? But here we said concrete, right? Concrete is impure, is heterogeneous. No, for the homogeneous mixture. What other thing did you mention? That is, no. God bless you. So salt and water, that is brine. Is that okay? Brine. So this is, or these are, now, or if I say sugar and water, now listen. One thing with what heterogeneous mixture is this, they form suspension. Not all of them, but many of them form suspension. Good. Now, what is now a suspension? We said that heterogeneous mixtures they form suspension. What do you mean by suspension? The suspension is basically a mixture where one substance is mixed with another, so it dissolves in it, it's mixed together, but they do that one does not dissolve in the solvent. Is that okay? So that is a type of heterogeneous mixture. Alright. Then we have the next rule, which will be okay. So let's treat colloids. Colloids. You understand that we have treated suspension, we have treated solution. Is that okay? Solution, suspension. It's not all heterogeneous mixtures that are suspension. But most of them are what? Suspension. Most of them are what? Alright. So now watch this. Let's go to colloids. Colloids. Okay. So how do you define a colloid? Exactly. So a colloid is a substance in which one other substance is dissolved. It is a mixture of two or more substances where one is dissolved in the other. Is that okay? But the that one that is dissolved is not totally dissolved. Do you understand? Right. So that is a colloid. That's a colloid. Right. So we said the substance dissolved in another substance. But okay, good. Now let's learn of the types of colloids, examples of colloids. Examples are. So now, it is imperative that you learn this table I'm going to give you. Now, one thing about colloid is this. Colloids have particles that are smaller than solution, but they have particles that are greater than suspension. Is that okay? So if we say colloid should be C, suspension should be SP. And so, and Okay. So what this is basically saying is out that this guy, huh? Are you with me? Is okay. So let me write this. Is the molecule, the particles of this guy, of this colloid, is less than the particles of solution. You get it? But less than the particle. So it's greater than the particle of solution, but less than particle of suspension. Am I wrong? Do you get it now? It is greater than the particle of suspension, particle of solution. Yes. So this colloid is going to be greater than the particles of solution, and the same colloid is less than the particle of suspension. Is that okay? So by the time you now write this in mathematical notation, you get that. So now let's talk about the table. So what? It's a table of colloids. So now we're going to have the colloid, the type of colloid, and the dispersed constant, that is the constant that is being, are you with me? Dispersed medium, dispersed substance. Eh? Oh, okay. Eh? Dispersion medium. And examples of such colloids. Okay. Now, the first one we should learn, is sol. The next one we'll learn is what? A gel. The next one we'll learn is aerosol. Aerosol, then what? Emulsion. Emulsion. And are you? And then there's a foam. Now, what substance is dispersed in a solid? The first substance that is dispersed in a solid is a solid, and is dispersed where? It is dispersed inside the liquid. Is that clear? The substance that is dispersed for the case of gel is a liquid and is dispersed where? In the solid. You see, they are just interchanging. You get it? Alright. Now, for aerosol, we have that liquid and solids, you know, liquid and solid are dispersed in gas. Do you understand? Okay, we're not going to give an example now. Example of this one now, solids. We have paint. Is that okay? We have ink. We have what? Butter. No, butter is. Did I give you butter? No, here is blood, not butter. Here we have a blood is a sol. Blood is a colloid. Do you get it? Water starch. Do you remember starch? And you make starch. Is that okay? So that is a sol. Now for gels, we have jelly, we have butter. Do you get it now? We have air gel. Do you get it? Those are all gels. Do you get it? Now how about aerosol? It's a liquid or solid dispersed in gas. If it is liquid that is dispersed in gas, you form a fog. Now if it's now solid that is dispersed in gas, you form what? Smoke. Is it clear? Good. Emulsion is liquid dispersed in liquid. You understand? Now, when you disperse liquid in liquid, what do you form? What's an example? Yes. Yes. You have milk mayonnaise. You get it? All of these substances are emulsions. They are emulsions. Next one, you have the foam. Foam is when you disperse a gas in solid. We have what? Gas dispersed in solid and what? Liquid, or liquid rather. So we have examples like our ladder. Our ladder what? Gas dispersed in what? In solid, right? Good. So that's the ladder. The ladder will form in soap. Soap. You understand? We also have rubber and foam. Alright. There's also one called whipped foam. That's one we use. So that's just so these are all the colloids. Now a very important thing you know of colloid is what is called what? The Tyndall effect. It's called what? Tyndall effect. It was discovered by Tyndall, so that's why it's called the Tyndall effect. So Tyndall effect is the capacity of what? Of a colloid to scatter light. Do you understand? So colloids have the capacity to scatter white light when incident on them. So that property is called what? Tyndall effect. Right. So thank you very much for watching this video to the end. Do want to subscribe to the channel and click the bell notification to get notified whenever I drop a new video. And I'm going to link a video in the description also that you can watch, to follow this series up. Right. God bless you as you subscribe.